Hey guys, I am going to kind of roll through this today because I don't know exactly how much time you guys are going to have due to the assembly. Speaking of which, that's where I am preparing for or working at assembly. Of course, I got called at the last minute, but that's how it works. Anyway, we're going to talk a little bit more about the normal distribution stuff that we've been working on. And like I said, I am going to kind of fly through this, so if you get behind or something, just ask Miss Eason to pause it or rewind just a little bit. I'm sure she won't mind. Or she's pretty smart. She could probably teach this stuff way better than I could anyway. So, anyway, let's talk about this thing here, okay? And remember, this is our bell curve. And we use it to determine probabilities for situations that are described as normal. And if you remember, these guys, this space in between here, we call this the area. This is, or each of these percentages represent the area under the curve in between these two markers right here. And remember, the guy in the middle is always your mean. That X bar right there is your mean. And we talked about the distance between each of your markers, and of course that distance was our standard deviation. And that standard deviation tells how spread out our data is from our mean. The bigger the standard deviation, the more spread out the stuff is from the mean. So we talked about that. Let's see, what else did we talk about with this bell curves? I don't know. Anyway, so we've got this stuff here. Okay, now let's look at a problem like this, and hopefully you guys had time to finish that worksheet, and I hope you guys all got them right. Shouldn't be too bad. But I want to look at a situation like, hold on, I got it somewhere. Okay, here it is. I want to look at a situation like this. All right, where we have a mean of 50 and a standard deviation of 5. Yeah, there we go. Okay, so let's look at something like this. We got a mean of 50 and a standard deviation of, you can't see that, there it is. Y'all know I'm OCD, I gotta fix that now. Okay, so let's look at something like this. Now, we know that when you see this word in a stats problem, especially normal distribution, you can just about every time think bell curve. So I'm going to get me a bell curve from, steal this one. And we're going to be able to draw a bell curve for this. And you don't have to do this part. All right, I don't need you to write this. I'll tell you when to start writing. All right, so help me make this bell curve. We know that what goes in the middle every time? The mean goes in the middle. And to get these other numbers down here, these other points or markers, we're going to add and subtract our standard deviation. So this is 50, this is 55, and add 5 again, 60, add 5 again, 65. Going backwards, we subtract 45, 40, and 35. All right, so when they came to ask us our questions, like this guy here said, what's the probability that X was less than or equal to 50? Well, it was easy. We just went to where 50 was right there, and we know that we're looking at all this junk right here, right? So we would add up all those percentages. And when it asked about 55, well, that was easy too. We just went to 55, and this is less than, so we just add up all the percentages that was less than 55. And then same thing for the 40. We just went to 40, and which was here, and we add up all those less than 40. So that was easy. But what happens when we get to something like 62? Where does 62 fall on this graph? Well, it would be somewhere like here, right? That would be about 62. And so if we want to talk about less than or equal to 62, well, that would be all this right here. Well, that's fine, but how in the world do we figure out what this is? And we know, like, from here over, but this little piece right here, we have no way to figure that out. Okay, Well, whenever this happens, here's where you can start writing, by the way. Whenever this happens, whenever you have an x value that doesn't fall in your values for your curve, we're going to convert that value to a z using this formula. Okay, I'll give you a second to write this down. Right, actually, don't write this down. Hold on. Okay, now you write that down. Had to put that little arrow in there. Okay, so you got this written down. Now, this formula is going to let us convert an x value to a z value. And then we're going to use this fancy table, all right? And you guys should have a copy of this table. If not, somebody can hand those out, please. All right, let's talk about this formula. Okay, first you're going to have, well, obviously this is z, and we're going to convert it, and it's going to have a fancy name. People refer to it sometimes as a z-score. All right, but in this formula, let's break this down. This x is going to be the current value that you're working with. All right, this x bar, you already know what that is. That is your mean. And this guy here, little Greek letter, anybody remember what it was? Sigma.
Okay, I need you to give these out.
Sorry, Miss Gordy just busted in here. And anyway, okay, so yeah, this is standard deviation is what this is. All right, so if you have these three things, you can figure out your z value. Once you have that z value, we're going to use this table, all right? And we'll look at how to use the table in a minute. Actually, let's look at that first, okay? So let's say that you have calculated a z, and let's say that z value ends up being, let's go at 1.62. I just want to show you how to read this on your graph, on your table. So let me go to my table, which is here. I hope y'all can see this. All right, so over here I have my negative side, over here is my positive side. 1.62, I definitely need my positive side. I'm gonna zoom in over here. All right, now if you look across the top here, let's see if I can go full screen. All right, if we look across the the side here, you get everything in tenths. It's counting by tenths. So I got 0.1, 0.2, all the way on down. Right, here's 1.6 here. All right, remember the value I'm looking for is 1.62. So to use this, I'm going to go to 1.6. And then to get 1.62, I'm going to go over. This column, if you look at the top, it says 0.000. So this will be 1.60. Over here I have 0.01, so this will be 1.61, and this guy would be the value for 1.62. All right, so this guy. Okay, that would be 1.62. All right. Let's say they gave me something like, let's look at the value 0.57. Let's do negative 0.57. Okay, well, I will go to my negative side. Go down to negative 0.5, and then go over to the column that is 7, 8. So it will be, if I can get this to go away. If I can get that to go away. Yeah, of course it comes back. All right, negative 0.57 would be this guy right here, right? All right, and let's look at one more. let's go with the tough one. Let's go with negative 2.8. All right. Well, if I get something like this, notice my other guys all had 2 decimal places. So what I want to do is think of this like it is 2 decimal places. And to do that, of course, I can just add a 0 at the end because it's after a decimal. There's no other real digits after it. So we're good. So this is the same as negative 2.80. Well, then all I have to do is go to my chart, and hopefully you can tell me before I get there. Negative 2.8. There's negative 2.8, and the 0 column will be here. So it'll be this value here. All right. So if you can read this table, you're halfway there. All right. Now, let's look at an example of how we're going to do this. Okay. All right. Now, we're going to use this same example. And like I told you before, when you do these, you don't really have to write every word of the problem. You want to get the main information out for it. So in this guy, you're going to write that the mean is 50 and the standard deviation is 5. All right, and we work from there. Now, if I drew my curve, all right, which I did on the a couple of slides back, I know that this 62 does not fall on my curve, right? I can show you that again. All right, if I draw my curve, 62 did not fall on my curve. So I need to change it over to a Z. All right, let's do that. I'm gonna move this. Actually. All right. So let's change it over to a Z using that formula. Now remember the formula was Z equals, I had X minus my X bar over my standard deviation. Let's working on out. Now the X I told you is going to be the current value, the value that you're working with, which in this case is 62. And then minus my mean, what's my mean again? 50. And that's going to be over my standard deviation, which is 5. All right. So all I got to do is work that out. Now, you can put that in your calculator. Tell me what you get. All right, hopefully you got 2.4. Okay, now remember we're going to use that table. This gave us as with 1 decimal place, so we're going to go make it 2.40. All right, now this becomes a problem because I converted this over to a Z. I'm going to rewrite my problem using the Z notation. So it's going to be probability this time that Z is less than or equal to,
Attention all classrooms, this is just a reminder that the Georgia Milestones testing and service will begin in 5 minutes in the media center. Thank you.
all right, that was Coach Lawler. Okay, so this is going to be now the probability that Z is less than or equal to 2.40, and all I have to do is look that up on my chart. So I go to my chart, 2.40, I'm going to go over to the positive side, go down to 2.4. That value is my answer, so 0.9918. All right, so this is the probability that a value is going to fall less than 62. It's that easy. All you have to do is use that chart. All right, let's do another one real quick together. All right, here I've got X is less than or equal to 47. Again, that does not fall on my chart, so change it to a Z. All right, this time it's going to be 47 minus 50 over 5. 47 minus 50 is negative 3. Negative 3 divided by 5 is going to be negative 0.6. And again, I want to use 2 decimal places. So negative 0.60. That's my bill, not yours. Alright, so I just gotta do, all I have to do is look this up on the chart. Alright, let's go back to the chart. Now I'm gonna go over to my negative side, and I need negative 6 or negative 0.60. It's gonna be right there, 2.2743. So, all right, I forgot to write this as a z, so I'm gonna write this as a z. Probability that z is less than or equal to negative 0.60. Yeah, I think it was 0.2743. All right, easy enough. Now, we got this third guy down here, and it's a little different only because the sign is different. This guy was less than or equal to, this guy was less than or equal to, this guy is greater than or equal to. All right, and I'm going to tell you 2 ways that you can go about this. Okay, so first of all, I'm going to get my z value. All right, so this is going to be z equals, I've got 34 minus 50 over 5. And I get negative 3.20. All right, and from there, this becomes the probability that z is less than or equal to negative 3.20. And now I need to look this up in the chart. But here's the only difference. Because this is a greater than or equal to problem, instead of just using the value, I'm going to do 1 minus that value. All right, I'm going to do 1 minus that value. And here's why. When I do my chart, all right, by changing this to a z, I converted it over where the mean is 0 and the standard deviation is 1. So it goes something like this. 1, negative 1, negative 2, negative 3. So negative 3.20 would fall somewhere over here, and I want all the stuff that's greater than is going to be all this stuff. Well, the thing about this chart is it only gives me the stuff that's less than. Less than is the other way around, right? It's be this stuff over here. Well, to get the greater than, I'm I'm going to take, I know the whole thing when I add it all up is 1 or 100%. So to get the part that's greater than, all I have to do is do 1, which is the whole thing, minus the part that the chart gives me, which is this yellow part here, and that'll give me my greater than. So anytime it's a greater than problem, I can do 1 minus that value in the chart. That's going to do it for me.
That's why you messed up. You can't give me my stuff. Hey, Mr. Smith.
You sent me some, I was about to say you some, I see.
My bad, I had some loud people come here. Ain't gonna say no names, Ebony. All right, so I finished this out. I just need to get this value. Negative 3.20 is here. So 0.0007 is there. So I'm going to do 1 minus 0.0007. And when I do that, I'll get 0.9993 as my answer. Okay. Another way to think about this, or another way to do it, would be to use the value that is opposite the z that you got. For example, I got negative 3.20 because this is a greater than. Oh, I made a mistake up here. I don't know if anybody caught it. I wrote less than here. I should have written greater than. My bad. All right, because this is a greater than problem, I can use the value that's opposite this. So I can use positive 3.20, the z value for that. And if you look that up, it'll give you the same thing. So, all right. I don't know how much time y'all have, but if you have time, I would like for you to try these 4 problems. Okay, same stuff. Try it.